Ladies and gentlemen, thank you for standing by. Welcome to the Pavement Preservation 2021 webinar series call. At this time, all participants are in listen-only mode. Later, we will conduct a question-and-answer session. Instructions will be given at that time. If you should require assistance during the call, please press star, then 0. I would now like to turn the call over to your host, Jason Dietz. Please go ahead.
Thank you. Thank you, Justin. Well, welcome everyone, and thank you for joining us today. My name is Jason Dietz, and I'm with the Federal Highway Resource Center, and I'm partnering with the Pavement Preservation and the Recycle Alliance, PPRA, on a series of these pavement preservation webinars focusing on pavement preservation. Today's webinar will focus on the storage and handling of asphalt emulsions. You will see a number of polls on your screen. We ask you to take a moment to answer those, and we will close them in just a few minutes as the presentation begins. We also encourage questions during the webinar and ask you to please take the time to respond to the evaluations at the end of the webinar. All attendees are on mute, but you can submit any questions through the chat function on your screen, the lower left-hand side of your screen, and we will answer those as time permits during the end. We will be offering PDHs on today's webinar upon request. So please let us know after the webinar if you would like to receive those or not. I'd like now to introduce our speaker today, Dan Swiertz. Dan Swiertz is employed with HG Meigs, a subsidiary of the Asphalt Materials Incorporation. His role includes technical support, research and development, and quality control of asphalt materials. He is also active in the academic asphalt research community through a relationship with the University of Wisconsin-Madison. Dan is a registered professional engineer in the state of Wisconsin. Dan, now I'd like, on behalf of PPRA and myself, Federal Highway, I want to thank you for your time today, and we'll go ahead and pass it over to you.
All right. Great. Appreciate that, Jason. Yeah, good afternoon, everybody. My name is Dan Swiertz. Thank you for logging on, spending the next hour or so with us. The topic of discussion today is storage and handling of asphalt emulsion. So I'm looking at these poll questions, and I think it's kind of nice. And the one on the which best describes your role in the asphalt emulsion industry, I'm happy to see that we've got a relatively even and nice distribution between these different roles, because what we've really designed today's webinar to do is give you kind of a high-level overview of the handling and hauling processes. So hopefully there's something to take away from anyone. Obviously terminal operators, plant managers, and so forth, but field support technicians, agencies, and everybody can really take something from this and understand what they're seeing, what they're receiving in terms of their asphalt emulsion products. So we're excited to present this information to you. Again, if you have questions, put them in the chat box, and we'll get to them at the end of the presentation here. So, Jason, if we can move the presentation, we can get rolling with this.
And Dan, I'd like to remind you about the webcam.
Oh, sorry.
No problem.
There we go. Talking to my screen, and now I'm even thinking to share it. So there we go. Well, welcome everybody. Thanks for joining us here. So what you see in this slide here, in the upper picture, is one of our terminals in Wisconsin as it exists today. The lower right-hand picture is that same terminal picture taken in the late 1980s. So I put this on here with a couple of quotes. What we see is a lot has changed clearly structurally, but structurally, we're seeing a lot of the same thing. Same type of tanks, kind of how they're set up. There's just more of them, right? We're still heating the asphalt. We're still milling the asphalt into emulsion, still storing it, still shipping it. So the point of showing you this and putting these quotes up here is to say that, let's not forget what we've already kind of learned and the experiences that we have, and let's use that experience to make our decisions moving forward. Automation, in other words, doesn't take the best practices out of our business. So let's kind of use that as the foundation for how we're kind of building through these slides and learning about the handling and hauling aspects. All the information that is included in these slides, you don't really have to take my word for it. What we did is we sort of interviewed a wide range of folks in the asphalt emulsion industry, from terminal operators and plant managers, facilities engineers, trucking directors. I mean, you get the picture. So what you see is sort of a compilation of many decades of combined experience in these processes. So we hope that you'll gain some useful knowledge for it. So, oops, clicking on buttons here. So let's kind of jump right into it. So we'll cover 4 topics today. And I think the easiest way to kind of frame this up is to picture maybe a full season at the asphalt emulsion terminal, or even day-to-day operations can work. We'll go through storage of the emulsion. So this is storage after the mill, essentially. We'll go through loading and hauling, obviously, getting the emulsion to the site. We'll look at some end-of-the-season chores, so unloading, cleaning, winterizing, and then, of course, you know, there isn't a slide about asphalt, or there isn't a presentation about asphalt emulsions that wouldn't be complete without, you know, an uh-oh, what now slide. So sort of a troubleshooting and how to fix a problem type of slide. So those are the topics for today. Essentially what we're trying to do is bridge the gap between production and application with this information, right? So after the mill, but before the products are necessarily applied. So this is not a presentation on safety. We don't intend it to be, but I want to start out with safety and continue to reinforce it as we kind of walk through these slides. You know, as an industry, as an asphalt industry, we're working with materials that are usually hot, sometimes hazardous, and oftentimes harmful to the environment if spilled or otherwise not contained. So it's not really a topic to be taken lightly. I put some pictures up here to kind of help us understand some safety aspects. So we have a fire extinguisher on the left-hand side, a windsock in the middle picture, you know, which comes into play for H2S monitoring and so forth. And then, of course, a chemical shower and eye wash station on the right. The point here is pretty simple. You know, we're not telling you what to do or what's best for you in your region. We're just saying don't do nothing. So safety is not something that should be taken lightly, and we'll touch on it again as we walk through. I just want to start there, kind of lay a foundation for that topic. So let's just jump right into storage. So as you can imagine, just like any material, there are a lot of options for storing asphalt emulsions that are available to us as producers. So it helps, I think anyway, to knock some of the easy variables, or I guess you could put it, quote, easy variables off the list first. Vertical tanks are generally always preferred in the asphalt emulsion industry. So they're preferred for practical advantages, tank farm geometry. In other words, you can pack more tanks in a given area. I don't think, if there are any production folks on the call today, I don't think there's a single one that would raise their hand if I asked, who's happy with the amount of space they have, right? We're always hurting for real estate. Vertical tanks can kind of help with that. More importantly, though, vertical tanks offer quality advantages for our product line. So with vertical tanks, they minimize surface area, right? So the amount of area of that finished product that's exposed to air. They're generally easier to mix. We'll talk quite a bit about mixing of asphalt emulsion later in this slide. And there are other reasons as well. I had an interesting question when we were preparing this slide deck. Are there examples of where we might see horizontal tanks? And, you know, I struggle. The terminals that I deal with in the Wisconsin market, we have 3 major terminals, really to find any examples of horizontal tanks, save for very specialty and niche applications. So an example of something might be like seal coat materials, which rely on a clay-based type of emulsion. So the stirring is much, or the homogenization is much more advanced for those type of materials. And then sometimes you see like water storage or hot water tanks as horizontal tanks. But most of the time, it's vertical tanks. So of course, The first thing that we can decide on is materials for construction, materials of construction. So we're going to abbreviate that MOC, and we're going to use that abbreviation for the next couple slides. It's going to follow us through. I've got a couple of considerations here in terms of chemical reactions, in terms of the storage temperatures. We're going to deal with that on the next slide. I put them here for completeness. Of course, sizing. We didn't really touch on that, but sizing is really going to be dependent on demand and availability of materials. So some asphalt emulsion terminals, just based on their production method, whether it's a batch type plant or it's a continuous production type plant, all of these things come into play. Sizing really dependent on your business model and demand. So we're not going to talk too much about sizing. But broadly speaking, we have 4 relevant MOCs for emulsion terminals, starting at the top, poly, moving all the way down to fiber reinforced. And we're going to spend the next slide really walking through the pros and the cons of where you might select one over the other. So things that might go into this kind of selection process. That brings us to this kind of chart that we developed. So what's hidden here is we're going to walk through those 4 categories of these MOCs, talk about some pros and cons and example materials. So this is going to end up being a relatively busy slide, but the point of it is that if you were to download this slide deck after this call, you can use it as somewhat of a resource, right? So we want you to have all the information kind of in one spot. So generally speaking, if you can list the pros and cons, the choice for a given application becomes a little bit clearer. So let's start at the top, poly or polymer type of tanks. So generally speaking, these polymer tanks are not very expensive. A wide range of polymers are available, which means you can cover a wide range of chemical compatibility and even temperature to some extent. They're non-reactive, easy to move. Generally speaking, though, that comes at the expense of structural capacity and heating capacity, right? So we can't place 300-degree asphalt, for example, in a poly tank. Where might we see these type of tanks around our terminal? We use them anyway for highly corrosive acids, in this case, hydrochloric acid for cationic emulsion production, softening oils, so these could be your bio-based vegetable type oils, good examples for poly tanks. And of course, we can walk right down the list with the other 3 materials. So carbon steel tanks are sort of the workhorse of the asphalt emulsion terminal. They take well to aftermarket modification. Pre-COVID anyway, they're relatively available. We see these tanks all over the place. We use them from everything from molten AC, so really hot storage, and then they're also good for like hydrocarbons and fuels, so diesel fuel or kerosene or anything like that. Stainless is more expensive, but what you pay for is corrosion resistance, right? So these tanks will generally outlast the life of what you need them to serve, but you're paying for it. So these tend to be kind of specialty applications for storage. Where we see them in our terminal is for raw emulsifier, so the emulsifier before production of asphalt emulsion. Last, I lump all fiber reinforced plastics, fiber reinforced polymer, FRP, kind of together under one row. I'd certainly entertain the argument if we want to break these out further. But the point is there's a huge range of available polymers, which means there's a huge range of available applications. They tend to be pricey though, and they don't take to aftermarket modification. In other words, if you need to install a valve or if you want to install a mixer, it's generally a little bit of a more laborious task. Where do we see those in our terminal? We see FRP tanks in our finished soap storage, so where the emulsifier meets water and we have a holding tank for finished soap solution, we use FRP tanks for that. So we'll get a couple of examples. Took some pictures around our terminal, tried to kind of capture as many as I could in as few pictures as I could, but on the far left-hand side, we see an FRP tank with a vinyl resin liner. So that, for us anyway, is a finished soap solution tank. This stainless tank next to it holds raw emulsifier. So we can see a mixer there. This is a tank with heating coils in it. And then moving to the middle, we see an uninsulated poly tank. This just so happens to be our HCl, hydrochloric acid tank. The small picture, kind of in the upper quadrant there, is an insulated poly tank. So this one holds our solution for anionic emulsion production. It's insulated because we have slight electric heat on this, or light electric heat on this particular material. And then last but not least, we have an uninsulated carbon steel tank. I chose an uninsulated one so that we could just see the bare outside walls. We'll talk about tank insulation in just a moment, but generally speaking, carbon steel tanks look similar to the one you see here. A couple other things to note as we're kind of walking through this. You'll notice that all these tanks are not sitting on the earth, right? They're sitting on raised pads. Even the stainless and FRP tank, which are sitting on concrete pads, are further raised from there. So this is intended to keep water away from the tank. For larger tanks, that might not be an economic option, but it can help lower life cycle costs a little bit. So I just want to put that out there as maybe a useful tip if you're thinking about setting up things. Is the best you can get water away from the bottom of the tank, or the better you can, the better off you're going to be. So. To insulate, right? That's the question. Do we insulate our tanks? And I guess the answer, if we have to say in the most simplest of terms, is yes. Almost all of our tanks are going to be insulated. In the last slide, we saw an uninsulated tank, but what you see here is much more common of what we'll see around the tank farm. This happens to be a 300,000 gallon insulated version of a carbon steel tank. So between this kind of aluminum siding, outer shell, and the actual tank skin is about 4 inches of mineral wool. That's kind of the chosen insulation. Mineral wool is hydrophilic, or hydrophobic, I should say. It does not like water. It's very fire resistant, which in our industry can be a big deal. It doesn't sag as much if moisture somehow gets in between the shell and the siding. So that's kind of the chosen insulation method. I guess the question is, why do we need to insulate, right? So that the answer is we do, and here's how we do it, but why? And I guess I'll offer 3 sort of reasons why we may insulate tanks. First is, generally speaking, it's much cheaper to maintain temperature than it is to ramp temperature, right? So we need the asphalt to be hot to mill. We generally need the finished product to be warm to use. So for many products, we can take advantage of the heat from the milling process, the hot asphalt and the warm emulsifier, to not have to add any heat. Second, from a quality standpoint, it's generally speaking a good idea to maintain temperature versus ramping up and down. So most emulsions don't take kindly to temperature swings. They like to stay at a single temperature or near a single temperature. So maintaining temperature is a smart move. Third, since we need these products to be hot to use, to facilitate production, in other words, for logistics, there's no sense in needing to heat tanks every morning before we need to get milling. So we keep them hot for production. So what do we mean by hot? What do we mean by warm? So here's some general usage temperatures. So I kind of moved from the top down here, from the raw ingredients down to the end use product, but generally speaking, hot emulsion ready to be milled is kept somewhere around 300 for standard paving grade type emulsions, paving grade type asphalt to make kind of commodity emulsions. Certainly there are exceptions to that. Finished emulsions can range anywhere from ambient, a lot of very low viscosity type emulsions. Tack coat emulsion is a good example of that. Can be kept at ambient, assuming your ambient temperature is reasonable. But most emulsions are kept somewhere in that range of about 120 on up to maybe 180 or so. I've got some ranges listed here. Don't take this as gospel. Take this as maybe some very generalized guidelines and examples, really. It's really best to consult with customer and your chemical suppliers to dial in exact temperatures. So I would be doing, I'm sure the terminal operators, plant managers, whomever who deal with this stuff day to day can agree with me here. We'd be doing our industry a disservice by not mentioning totes, right? So other storage vessels. IBC stands for International Bulk Container. They're those big square poly plastic things that you see all over the place. We use them really for smaller scale type of products, things that we may not make a lot of, but we need the chemical for to make occasionally. Specialty type products that might be very, very low dosage are good examples of where we might use totes. And I'm going to say this, and I hope I don't regret saying this, but we do see some customers that use totes for very, very limited storage of finished products. So, tack or something like that. Not necessarily recommended, but I put it here because it is relatively commonplace in our industry. Got a lot of advantages. They're durable, they can be reused if taken care of properly. But I put this picture up here. It's a tote farm, right? They take up a lot of space. They take up a lot of real estate. So maybe that's their primary disadvantage. Of course, drums are available, even less reuse value than maybe totes do, but they serve a purpose as well. The only other thought while we're on this slide is you'll notice with totes is because of the nature of which they're constructed, they're translucent, meaning they allow light through. Also, they all have like a screw-on cap on the top. That's how you vent them so they don't pull a vacuum. You got to be really careful making sure that you're storing these things out of sunlight if they need to be, and certainly sealed from the atmosphere. Some chemicals will pull moisture from the atmosphere, some will react with moisture, or others can degrade by UV radiation. So I show a picture here of some latex totes that are covered with a tarp just to avoid some of that. So I'm going to, here we go. So a couple more pictures here just to sort of demonstrate the utility of such containers. Oh, there we go. I was looking for my pointer as I was kind of talking here. So here we see kind of a forklift hooked up with a tote. You get the idea. This is one of the advantages is these things are portable. They come with a Camlock ball valve on the bottom. You can hook them up to a pump. In this instance, pumping to a small blending unit on a floor scale for soap production. So for terminals that make a lot of different products, specifically make a lot of different products on a non-routine basis, meaning you don't make the same thing every day, this setup can be very advantageous. So we do a little bit of both at all of our terminals, and I suspect that most folks do as well. Accuracy can still be maintained, quality can still be maintained. It's pretty common practice. So we'll talk a little bit about heating. You'll notice here there's no heat elements on this tote, on this pump, or in this blending unit. They do make tote heaters. They look like horse blankets, like electric blankets. But we'll talk about heating more in depth in the next few slides. My pointer out of the way. Whoops, stop my webcam. So the last bit of storage information that I want to talk about is specialty scenarios. So here we have a picture of a bermed area, a concrete bermed area surrounding our fuel tanks. So these would be like our diesel fuel and our kerosene tanks. The second bullet point here, though, maybe should be first, is that always default to local regulations. There are some states, some areas that do not allow certain chemicals to be stored certain ways, reporting, all of these things. So I'm not giving you a recommendation. I'm just showing you an example. This is a fuel tank with concrete berms. So enough said. It's just another example here. So maybe the most common, but certainly a very common question that producers get asked is, what temperature should we be storing a given emulsion? It's a very common temperature. Folks kind of have the misnomer that all emulsions are used at cold or ambient temperatures. That's not exactly true. Certainly colder than hot mix type of temperatures, but generally speaking, elevated above ambient. So the best answer, and the best answer any engineer can give for any question is it depends, right? What's the best storage temperature? It depends. So most of it depends on end use, so what you're trying to use this product for, and then some of it depends on the specific product properties as well. So let me give two examples. CQS-1H is a typical emulsion used in the microsurfacing industry. It's not uncommon for contractors to specify plus or minus 5 degrees of a specific temperature they would like to take delivery of that material, because so much of the microsurfacing process depends on a chemical reaction. And of course, chemical reactions are at least in part driven by temperature. An example that would require a high temperature by way of product properties itself might be chip sealing emulsion, like CRS-2P is a good example. So the 2P is high viscosity polymerized emulsion. We need a high viscosity emulsion so it doesn't drain off the road when we spray it, but because it's a higher viscosity emulsion, we typically have to heat it up relatively hot to get it to spray uniformly and through our distributors. So it's not uncommon to see rapid set type emulsions used in the chip seal industry as high as 180 or so. We'll talk about how high is too high. You know, emulsions are water-based. They're going to boil. You're going to lose water after a while. But I just want to point this out is they're not really used at ambient temperatures most of the time. Most of the time there's actually heat on them. Here's an example, this picture that I've got on the right-hand side here. This is taken on one of our tanks out in our tank farm. This just so happens to be HFRS2, so high float rapid set. We use it for chip sealing up here. And because in our region, the feedback we've gotten from our customers is that they like to spray the product between 170 and 180. It's where they get the best performance. That's where we maintain the temperature. So the point of me telling you this is this last statement here. So these ranges need to be flexible. Listen to what the customer needs. Listen to what the market needs for your given region and climate. So our terminal operators are trained in these storage temperatures. They may not need to know exactly what the product is used for. They just need to know that for this product, this is the storage temperature. So it helps to kind of keep that hard copy, as it were, right? Not everything is automated. So based on the desired storage temperature, plant capabilities, and so forth, there are really 4 methods of tank heating that are available. Now, I'll say that most terminals, in my experience anyway, in our experience, use some combination of these. So what is best is really dependent on your region and what you're trying to do. So don't construe this as necessarily a recommendation. It's just an explanation of how we go about heating tanks. So let's kind of walk through these. So like I said, nominally 4 methods of tank heating. I kind of go from like your highest level of complexity to a little bit lower complexity as we work down. But steam heating is very common if you're taking in hot asphalt from rail cars, barges, things like that are oftentimes heated by steam. Hot oil is a very robust system for maintenance of molten AC, so keeping molten AC at a high temperature is a good option for hot oil. Glycol systems typically used for storage of finished product emulsion below that 200 Fahrenheit type of range. And then these other two, hot water, you do see folks use hot water quite a bit for maintenance temperature on emulsion. We don't use it at our terminal here, but it's fairly common. On small scale applications, and actually on growing larger and larger scale applications, you see electric and portable type heaters. So we use electric heat on some of our raw emulsifier tanks, on our finished soap solution tanks, but not on any of our finished product tanks, just by way of how our terminal is set up, but not that it can't be done. So here's where I give a cautionary tale. So the picture at the right here where my cursor is hovering over is a filter insert taken off of a distributor truck. And what this distributor truck was holding was cationic rapid set emulsion for chip sealing. And this customer could not get the product to spray properly. As it would turn out, it was a spray bar and nozzle geometry problem, not a material problem, so I can absolve myself of any issue there. But what happened was most distributors heat product by direct fire, so they our fuel puts direct fire into heating coils into the material. The problem with direct fire is without careful consideration of material movement, you can get localized overheating. And this is true of any type of heating, by the way, but direct fire does tend to be a little bit more troublesome. And what you're seeing here is broken emulsion. So direct localized heating over that 190, 200 Fahrenheit range, the emulsion began to break. It clogs the filter with the residue, and it's really a bad scenario for everybody involved. So really the constant temperature, so avoiding temperature swings and keeping the temperature well below the boiling point is really the way to go. So that's the tank heating aspect of it. Now we have to move material from tanks to the loading rack, to the trucks and so forth. So obviously we need lines, we need asphalt lines, we need oil lines, we need all sorts of different runs in our terminal. And all of those lines in the terminal are also heated, right? So collectively, as an industry, we call this heat tracing. So heat tracing just means you're tracing the length or the run of a pipe or a line with some sort of heating element. So for any of the terminal operators kind of listening in, troubleshooting heat tracing is probably top 5, if not top 2, most frustrating tasks at a terminal, right? These are the things that always something seems to be going wrong with them. We're going to look at a few different options here. Again, what's best for a given application really kind of depends on a lot more local properties. There is no one size kind of fits all here. So there's really 2 basic methods for heat tracing. There's electric, and then there's non-electric. So non-electric would be like steam or hot oil. So these are very robust systems, and if you can take advantage of excess steam, if you have an oversized boiler, for example, these options can be very compelling. Generally speaking, startup costs tend to be prohibitive for these systems for most asphalt emulsion terminals, so you see more electric type of heat tracing than the non, but there is quite a bit of non-electric heat trace out there as well. Obviously, the primary con with electric type heat tracing is you're tied to the electrical grid, right? So if you're in an area that gets a lot of lightning storms, have difficulty with power surges, maybe that's a consideration that you have to account for in selecting these kind of heat traces. I want to mention kind of before we move on, just because I'm looking at it here, it really, and this is, I have no affiliation with this. I have no idea where it even comes from. But if you were to Google heat tracing systems, if you were to copy and paste this into a Google search engine, there's a PDF that will come up, and it's a better resource on the topic than I am. It's very in depth. If this is something you're interested in, I just want to give that to you. But if we move back now to the topic at hand, for electric systems, there are basically three types. There's this mineral insulated, which is this quote, MI cable. That's a series circuit type constant wattage. Then there's what's called a parallel circuit constant wattage. And then there's variable wattage type of systems as well. All have their pros and cons, and it needs to be kind of thoroughly understood what those pros and cons are for safety and process control. So the intention of these slides is to show you examples. So let's do that. So walking around our terminal, because we have a relatively, I'm not going to use the word old because that's derogatory, but it's a legacy model. So we've got a lot of systems that have been in place a long time that offers us the ability to have a lot of different systems to look at. But what we see here is MI cable on heat transfer lines, and you can see where the thermocouples get into the lines here. The nice thing about MI cable is it's very accurately controlled. We can see a control panel here for all the different thermocouples maintaining temperature. They're digital thermostats. Troubleshooting is relatively straightforward. The issue with MI cable is it's great for long runs, but you have to cut or order the MI cable to that run, meaning it's not so easy to work on in the field. It can't be spliced as easily as the other ones. If any bit of MI cable goes out, the whole system will go down. It's a series type of circuit, so whether you consider that a disadvantage or not, it's the fact of the matter. So on the right-hand side here, I'm going to pull my little cursor. We see kind of the other end of the spectrum, the kind of caveman end of the spectrum. This is just a constant wattage system. This pipe is usually insulated. I was able to snap this picture before they got the insulation back on, but what you're literally looking at is the actual heat trace taped to the pipe, and then insulation like you would see this type of insulation would be put back around the pipe. So these units are essentially plugged in. They give you pretty good control. They're just plug and play. They give you good control for lower temperature applications. But the real advantage, honestly, is simple installation. You can cut to length. You can splice them in the field. You see a lot of them. They tend to be a little bit problematic in terms of troubleshooting, though. If a line of this heat trace goes out, you may not know which one goes out. The asphalt in the line may just not flow, and you don't know why, because part of the heat trace is out. Hence why I say troubleshooting heat trace is one of the worst things that could be bestowed upon you. I struggled to find good examples of non-electric at our terminal, but here's one that's hot oil. So this is a hot oil heat trace going up into an insulated pipe here. You can see the concept is the same as electric. You know, you're wrapping a pipe with something that's hot, and then you're insulating it. It's really that easy. Now, it's been our experience that almost all pumping-related issues at the plant are heat trace issues. It can be a very time-consuming process. It's labor-intensive, difficult to troubleshoot. My point is it pays to set up a robust system. So really understand the pros and cons. And there are certainly vendors out there that can help you with this. But set up a robust system for your needs. The reference on the last slide is a good place to start. There are a lot of equipment vendors. Any vendor that I mentioned by name is purely circumstance, but you can Google these things and find them online pretty easily. Depending on the logistics of your terminal, our terminal here in Portage, Wisconsin takes rail cars. Rail cars are exclusively heated by steam, so we have to have the ability to use steam heat, and that's what you see here. So steam input lines to the coils of the tank, and then the asphalt comes out the bottom once it's cool enough to pump. I put this here just as an example picture of what steam kind of heating might look like. So terminal model, business model really dictates, whether this is something that's required or not. Some folks just bringing in by truck might be different. So, anyway. We saw pump insulation. I'm going to back up 2 slides if you'll excuse me. I know paging through is never fun, but what you're looking at in this bottom picture I probably failed to describe. So this is an asphalt pump. This is a gear pump that's housed in a casing with its own MI thermostat, mineral insulated heat tracing thermostat. The asphalt pumps need to be heated, right? They're cold, big pieces of steel, and if we don't heat them, we can have problems pumping these materials. So this is an example of how a pump can be heat traced with MI type cable, but the point of this slide I'm going to show you, this slide, is another common option. So this is called canister heating or cartridge heating. So what I've got a picture of, I just stole this picture from Granger. That the actual layout might be different. But this is what it looks like. These little cartridges plug right into the casing of the pump. They're electrically heated, extremely temperature stable, able to hold a uniform temperature very well, so it's a robust system. you see quite a bit of this as well. This is a direct electric heat into the pump casing itself. So it's a reliable option, you know, if it fits budget and need for you. Again, I mentioned vendors, right? There's been a lot of advancements recently on heating type technologies and terminal design. We're not really forced to use one or fewer, you know, options in a given region. Here's a unique kind of plug and play example. So this has a circulating oil heating type of system. You can see how it kind of plugs into the sidewall of a tank. Kind of a neat thing here. Again, sometimes the choice is made for you. You know, plants like ours that have systems already built in from years gone by, sometimes it doesn't pay to overhaul. It pays to just maintain, so that's what we do. But do your research, reach out to vendors, reach out to other emulsion producers, and we're generally a pretty open industry. So, okay, so let's revisit storage. So here we've listed some best practices in our experience for mixing, shelf life, storage type materials. So most of our tanks are outfitted with sidewall type mixers, like the one that you see here. I'm going to move my cursor here. This is a sidewall mixer. So I'll show a picture on the next slide of what the inside would look like, but what you're looking at here is just a simple electric motor turning a shaft and a mixer. The ubiquitous bucket is to catch one of the cons or one of the downsides of sidewall mixers is they leak, right? When they leak onto the ground, so we hang these buckets. But another option would be what's called a top-mounted. So a top-mounted, you can picture it as sort of like an immersion blender, right? It's something that comes in from the top of the tank and it mixes that way. They don't leak, right? They are typically more expensive, different types of maintenance. Again, we use sidewall tank mixers, but I want you to know that top-mounted exist as well. You know, it's my kind of opinion that tank mixing can be a little bit overstated. How much mixing and how often to mix. In general, given relatively short storage times, most products are going to do fine with just a very gentle turning over. So there's no need to be shearing these materials to bits. Certainly you want to avoid pushing air, splashing, frothing. A lot of emulsifiers that we use are also foam positive, so once you begin to build foam, they'll continue to build foam. Anyone that's loaded trucks probably knows that firsthand. And really it's best to pump as little as possible. Move the product as little as possible. A gentle turning over is really all that you need. But you do need to consider mixing because temperature segregation is a real thing, especially in tall vertical tanks. So mixing can help make a more homogeneous mixture, which obviously helps in the QC, QA world. Where taking a sample from one valve and one part of a tank, you need to assume that it's representative of the whole tank. It can make field performance more consistent as well. If each load leaving your terminal is the same temperature, you'll generally see the same performance once it kind of hits the field. So the question that you'll get is, or that we'll get is shelf life. How long is this stuff good for, right? I want to make the brief mention before we just give a number that shelf life is something that can be designed. In other words, if this is a pinch point for you, talk to your chemical supplier, talk to your customers, and figure out the best way to produce that emulsion to last as long as you need it to last. I mean, you don't want to be throwing away chemical on one side. You need the emulsion to eventually break on the other side, right? You need it to turn back into asphalt. So there's some healthy balance between the two, but it is a design parameter. You can extend or shorten shelf life considerably. Typically, though, commodity type emulsions, flow set, so this would be something like tap coat, handled properly on the order of months is not unusual. Rapid set, like a chip seal type emulsion, might be on the order to weeks. Peak season, you hope that you go through those products faster, that you don't even have to mix them. You're making them faster than you can, or shipping them faster than you can make them most of the time. But again, talk to your chemical supplier about your needs. It's not a one-size-fits-all type of application. It needs to be kind of a careful balance. So I promised a picture from the inside of the tank, and I'm going to deliver on this slide. So this is a mixer put into a stainless steel tank. This is the outside. This one's brand new, so no bucket hanging off of this one just yet. Give it a few months, and we'll have a bucket hanging there. But so what you're looking at is the outside of the tank, sidewall looking in, and then on the inside of the tank, it looks something like this. So this is a very common setup, like a propeller type of mixer. Something to note, I hope this picture, yeah, you can kind of see it. So these mixers are generally put into these tanks off perpendicular, meaning they don't intersect the tank wall at a 90-degree angle. There's some angle of repose, and the reason for that is turnover of the tank. So this happens to be a 30,000-gallon tank, and there's one mixer, and that's sufficient. And the reason it's sufficient is because the vendor that we use helps us design these in the right angle so that we need one mixer, and it takes care of our needs. Again, err on the side of less mixing the better, and that's kind of the point here. Vendors can help you size these. There's a number of vendors out there. I'll stop short of giving trade names out, but if you search, you'll find these as well. So I think that covers mixers to a pretty good degree here. Let's spend a minute talking about pumps. So by far, gear pumps are the most common in our industry for high viscosity fluids like asphalt. This is a typical gear pump here. They tend to be pretty bulletproof, simple to fix. They're widely available, easy to heat trace. They come in canister models as well that can be electric heated. But you do see other types of pumps, centrifugal, things like progressive cavity pumps, diaphragm type pumps. We'll give you examples. We'll show you some examples of where we might see those. But best practices generally is to heat these things to the mid 150s or so before use in order to keep them from plugging up. Typical range. People ask about sizing all the time. Sizing is obviously dependent on volume and demand, but let's say that most of what we are dealing with here for an asphalt pump is in that like 200 to 300 gallon per minute timeline. So it'll take us somewhere between 25 to 40 minutes to fill a 5,700 gallon tanker. So that's pretty common. It's a balance between efficiency and safety, right? So somewhere in that range. It's all customizable, of course, to your needs. Simple slide, but completeness. Here's a diaphragm pump on this side, moving hydrochloric acid. Flow rate's not our concern. Pump longevity is our concern. So that's the choice here. Let's do another example. Here's a progressive cavity pump used for really, really high viscosity gel. So really can't be pumped any other way than a positive displacement progressive cavity type of pump. Again, things that you just need to consider with different vendors depending on your specific situation. So looking now at some just general terminal best practices, we're looking down a finished product tank farm. So I'll call out just kind of a couple of noteworthy observations as I've got them circled here. So first is red, tank labeling. So this is just an example, but how our tanks are labeled. So we've got the number of the tank, in this instance 39. This happens to be a 40,000 gallon tank, and it's an FP or finished product tank, and this is the product that it's holding. Green, we've already kind of looked at one of those. You can see what it is. It's the temperature gauge. So again, we can trust automation as much as we want, but this is a robust system to double check that, right? So this is a dial gauge type thermometer right into the side of the tank. Third is this yellow. So what you're looking at here is sort of the caveman way of measuring volume in a tank. So it's a simple but reliable float system. So our plant operators know that, so if we're loading trucks by ourselves, we know how many feet or how many inches, which are the small demarcations on these, it takes to fill a trailer. So we know where the float starts and we know where it is at any given moment. We know how full the truck is. In other words, you can load a truck by standing next to the tank and not having somebody on the loading rack all the time. What's next? Blue. So the last one here is blue. Is similar to the tank labeling. This is just labeling of the product lines. So you probably can't read this, but there's a line that says cationic and there's a line that says anionic. Of course, HFRS2 is an anionic product, and that is the valve that's open, right? So you might ask why we even have a cationic for emergency use, right? In case this tank has to be used for something cationic in the future, we can do that. Moving up to the load rack, again, clear labeling of lines is what we see up here. So it helps to make sure, everybody knows which line is carrying what. To this point in our terminal, so we were just in the tank farm, which is over here. Now we're in the loading rack. You can see all of our lines have been segregated, meaning they are single use, either anionic or cationic. The only place in our terminal where these lines ever meet is the loading spout itself, just this small little loading spout. So this eliminates essentially any compatibility issues we have with products in our terminal. So again, cationic and anionic don't play well together. Keep them segregated that way. So our terminal is pretty hands-on. There are a lot of automated systems out there, but they work in the same concept that you're kind of seeing here. And of course, way down at the bottom, I just want to draw your attention to the tires of this vehicle are chalked, meaning this truck is going nowhere until this tank has been verified full, closed, and sealed. So safety at all times. So let's play the do's and don'ts part of loading. So all of the do's. So we talked a little bit about safety. Follow your company's PPE guidelines, chuck the vehicle, turn it off, et cetera, Very importantly, we'll talk about this on the next slide, verify the trailer is empty. Here we can see the splash plate of this trailer. That tells us that this trailer is, for most intents and purposes, this is an empty trailer. It can be loaded. Understand what product is to be loaded versus what this trailer held last. That can be very important. And then I put a note here about foaming. We'll talk about dilution in a little bit, but just note that excessive splashing, some emulsions are foam positive, and you can have issues related to foaming. How about do nots? So if those were do's, the do nots are relatively simple, right? Don't load onto a partially filled trailer unless you're absolutely certain of what you're loading onto. Don't mix water and oil. That seems pretty simple. And then I'll give you an example of don't abandon your post. Don't be afraid to black flag a trailer. In other words, if this doesn't seem right, shut it down. There's nobody's life, nobody's safety is worth another load out the door. So this is a busy, but I think kind of interesting and important slide. So this is a training tool that we use at our terminal. I'm not suggesting you need to use it, but essentially what it's doing is it's asking the terminal operator every single time to say, what's the product I'm loading? What was the last product in the tank? And anytime that you see a green square, that's green, good to go. Anytime you see red, that means stop the system, do something, assess the situation, etc. Anything yellow means understand what you're doing and be vigilant. So what do we notice? The majority of this chart is yellow or yellow to red. So this is a process that shouldn't be taken for granted, right? There's a lot of instances where something can go wrong in our terminals, and simple vigilance on this and training can really ward off a lot of those problems. And it can help on the other side too, for the agency folks calling in, for the field engineers calling in. This is a great way to begin troubleshooting. Contamination is a real thing, it happens. Understand what we loaded, what was the last product, and what could be any sort of problem with mixing the two. I don't intend to spend time on these. What I'm putting up here, this is like example to practice, right? I can talk all day long about what we should do, where does it come into play in real life. So the recommendation I will give is develop some sort of a system to document and learn from issues. Issues are going to happen, but as long as we don't repeat the same issues over and over, we can move forward as an industry, really, and as your individual company. These are two examples where an employee threw up a black flag because there was something in the trailer he or she didn't like. One of them was water, one of them was gas, some sort of fuel. These were instances where shut down the operation, figure out what to do next, don't load the trailer. Just a simple example. Here's an example where everything is seemingly done right. In other words, if you're to read through this on your own, or if you're a quick reader here, they've boiled out trailers many, many times in the past. They thought they left enough, or tanks, I'm sorry, many, many times in the past. They thought they left plenty of headroom, but because they didn't account for a formulation change, which resulted in a different outcome than their experience had told them would happen, they experienced a boil over on the tank. So the point here is, again, proper training, document to learn from it, and be vigilant, right? Don't walk away because everything seems okay. Verify that it's okay before we walk away. Why does it all matter? You could say, well, Dan, these are your problems. You're the terminal guy, so if I don't see it, it's not my problem. Well, it does matter. You know, there's kind of a human element to this. So this is a trailer that had water in it, or emulsion, I don't know what, some sort of liquid, and hot AC was put on top of it, hot asphalt. This building is 16 to 20 foot high based on the trailer height, and you can see we well exceeded that with the foaming and volcano of molten asphalt. So not a fun scenario. And I can tell you that this happens more often than maybe any terminal person on this call would like to admit. So again, cautionary tale. You know, an almost ubiquitous product in our industry, the terminaling industry, shipping industry, is tack, and tack is almost always diluted. So let's talk a little bit about dilution mixing. So understand the specifications versus we get handfuls of folks that come in here and just say, we want tack. Well, tack's a lot of things, right? So understand what it is you're asking for based on the specification. Most tack starts life somewhere around 60 to 62% residue, but it's used somewhere between 30 and 50% residue. Well, that changes dilution from 1-to-1 to almost 2-to-1 or 3-to-1. So understand specifications are getting more complex. For end users, it's very important to understand the aspect of dilution. For the folks actually doing it, it's always water to emulsion, not the other way around. Use water that's a similar temperature than the emulsion, and it always, always, always pays to do a little hand mix test first. Check the compatibility of the water. You might say water is water, but I can tell you different regions with hard water, soft water, different emulsion chemistries, it matters. We talked quite a bit about overpumping and splashing. I don't think we need to revisit too much, but do your best to not overpump and splash. And understand that not all tack is created equal, right? So there are some grades that should not be diluted. Some should be diluted with caution. They can behave very differently. So do your homework ahead of time. Lab testing is always good. And then last but not least, diluted emulsions are inherently unstable. They were made to be stable, but the dilution throws off that chemical balance, so they won't last forever. I can tell you that the majority of non-compliance claims that we get at our terminal are from the tack side of things, and it's usually because of storage and handling of diluted emulsion. Folks not understanding residue contents or not understanding handling. So hauling, so again, our observation, so most modern trailers are safe and reliable. So I mean, this is a lot of pretty straightforward information, but hopefully some of this can be useful. How we spec our trailers and so forth. We like to order air suspension for drainage. So what you're looking at here is I tried to take a picture against the level of a trailer unloading emulsifier, and you can see there's just ever so slightly a few degree slope in this trailer, enough to get a full drain on the trailer. So it's nice if you can't use geography to drain. In other words, you can't build a hump or something like that. Many terminals will build some sort of small, elevation change, totally at your discretion. So our most of our trailers are insulated, right? But we usually don't have heat on our trailers. And what we see, and we use Wisconsin as a case study, relatively cool climates, we just haven't had an issue. So we'll typically see, a 10 to 15 degree drop over a 24-hour period in our trailer, and maybe just a little bit more in cooler weather. And that's really all the time that we have these on the trailer anyway. So we just haven't had a reason to have heat on our trailers, even this far north. I'll tell you, it's very common to have second shift or third shift folks load trailers for the next day. So it's just not a problem. I mean, you can hold for 24 hours or even 36 to 48 has not been an issue for us for most applications. So take that into consideration. Big ticket item we get asked a lot. I interviewed 2 of our trucking managers is, do we designate cationic or anionic? Meaning, do we quarantine trailers? It's funny, like so many things in this industry, I got 2 very different answers. Up here, we've never had an issue. We get a full drain on our trailers. In other words, we drain as much liquid as we can, and we've never had an issue swapping. Believe it or not, he thinks that the company 1 manager thinks that moving between them helps with trailer longevity. I don't know if that's true or not, but that's what he thinks. The company 2 manager was just the opposite. He designates trailers cationic and anionic. They never swap them. They use them for one type of emulsion for the entire life of the trailer. So you can see there's really not a one-size-fits-all, other than you really can't be mixing bulk quantities of these type of materials together. So the only other quick point I want to mention, you really can't see it on this trailer, but most trailers store like an 8 to 12 foot hose for unloading, like the one that's probably being used to unload right here. Maybe I can just point to that one. Hoses are cheap, replace often, keep them clean. Contamination's a real thing. I just want to point that out. It's one part that gets kind of overlooked in winterization chores, and it's a small price to pay for compliant material, really. So be cautious. Samples from trailers are often tough because there's no mixing in these trailers, especially if you're sampling from distributor bars. So just understand how compliance can be affected by how these materials are stored and sampled. Drain hoses after every load. I like this picture to kind of lighten the mood. What this is a tank we were doing maintenance on. You wouldn't normally see this, but the tank was drained completely of liquid asphalt and then allowed to cool before the employees went in to cut out defective heating elements. So I call these asphalticles. They're just liquid asphalt that's dried in sort of this icicle type of manner. But this slide just offers some cleaning and winterization trailers. I know we're on like the other side of that now. This was first given in the fall, and this was a particularly relevant topic, but let's walk through it anyway for completeness. So on the plant side, water-based products typically need to be boiled out, right? Freezing is a problem. So we'll boil out our tanks every year and recover the residue. Asphalt's just kind of left to cool. So consider compatibility if you're going to have tank turnover. So raw emulsifier, anti-strip technologies, most tanks have some sort of a heel, meaning some sort of amount of liquid you cannot get out. If you are going to turn that tank over to a different material, just understand that compatibility. There are companies that can neutralize. Waste Management's one. I'm sure there are others, but you can get tanks kind of revitalized, cleaned out, ready for storage of other materials. I went to the well for answers on trailers, like I did on the last slide. Same 2 managers, same 2 different answers. So how do we get our haul trailers ready for the off-season? So the first manager uses hot AC to flash off liquid, and then we pump it off, basically just to kind of call it rinse. The other company, they simply just open the trailer. That's it. They open the trailer, let it drain, and then they're good to reuse. So lots of different ways to kind of to skin the cat here. So again, I'll just kind of reiterate the importance of preventative maintenance, right? So just like your commercial or your pedestrian vehicles, take care of your vehicles here, and they'll take care of you. All right, so no webinar is complete without in troubleshooting. So let's walk through a couple of, on this slide, just some very common things that can go wrong in a terminal or out on the road, and how can we fix these things. First of all, pumping. Most likely a heat trace issue, right? We talked a little bit about heat trace. I just want to caution you that defective heat trace results in slugs of asphalt. Slugs of asphalt tend to come out with force, not unlike a bullet from a gun. So just careful getting those kind of cleared out. Material that's broken in the tank. So the first thing to do is verify, do you mean broken, like it's solid, or it's just beginning to settle and thicken? Because if it's just beginning to settle and thicken, a lot of times you might be able to buy enough time to move it just by very gentle agitation, but I would suggest using it as quickly as possible. If it is broken, if it is just solid, can I just add more emulsifier, mix it back up? Generally speaking, the answer is no, and that can also be very counterproductive. It can make the problem even worse. So what you're kind of left with is, can I remill it? Can I do something with it? Some plants do remill often. You may need to add more or different emulsifier during the milling process. Monitor residue percentage and pH and use it quickly. Sometimes you can get away with that. Maybe a better option, if demand is there, is consider changing the grade. An example might be a rapid set emulsion that's beginning to go bad on you. Changing that into a medium set type of emulsion can be a good option. Last but not least, boil out for another application. In other words, if there's nothing we can do with it, a lot of times we'll ramp the heat to a point where we'll get all of the water out of it. We'll test this material, and we will find a new application for it. It's never really truly waste. It's used for something. But understand compliance, understand the quality of the products can be affected. So just some things to kind of keep in mind. These are just common what-if type questions that we get a lot. So let's wrap it up with this, kind of the Cliff Notes edition of what we talked about. So if we had to just kind of pull some bullet points, you know, if you had to say in an elevator speech, what do we take away from this? You want to maintain consistent temperature, avoid frothing, over pumping, otherwise shearing your material. You really want to keep temperature as close to use temperature as possible. Mixing's okay, frothing is not. In other words, mix only as much as you need to for quality control, for consistency, but no more than that. We'll typically mix some of our 40,000 gallon tanks once a day or once every other day for about 30 minutes. And then we'll take samples and make sure everything's okay. But sometimes on the weekends they may not get mixed, and that's perfectly okay. They're going to be fine. All right, warm lines are happy lines, right? So this goes back to heat trace issues. So keep everything warm, and you'll avoid a lot of problems. Vigilance from a loading standpoint. There's a lot of training tools out there. Use them. Somehow track, you know, day-to-day activities and black flag events and so forth, so that as an industry we can learn from them and do better. And then kind of tongue-in-cheek, but I like the picture. Probably shouldn't like the picture, but safety always. So this is a chip sealing operation that you can imagine was very promptly halted after this photo was taken. So, but honestly, though, safety always. You know, this is an industry that can have a lot of places where we can slip up. So keep an eye out for each other. I want to give you some resources. So maybe the best one, on the PPRA website, there is a tab that's called Emulsions, simply enough. And if you go to the Emulsions, there's another tab that's called Emulsion Resource Center. If you can't find it on this, I don't know if it exists. I mean, this is a great resource for you, free information you can download, print out. It's there for you. So like I said, this is a very open industry. Ask, and generally speaking, you will receive. More helpful links. So just a few here. Again, all downloadable stuff. You want to make a binder or you just kind of want to peruse through it at your own leisure. But again, because these slides are available, these links are available, go to them as you see fit. I'm going to just very quickly turn it over to Allie and Ann, and they're going to kind of present what's coming down the pipe for the next PPRA, and then we'll wrap it up with questions. So just hang tight. They'll introduce kind of what's to come for PPRA, and then we'll come right back.
Thanks, Dan. We really appreciate your presentation today, so thanks again for taking the time to share with us. Our next webinar in the series will be on June 17th at 2 p.m. Eastern, and that will focus on chip seal equipment and calibration. We hope that you'll all join us for that. To register, you can follow the link that's up on the screen, or you can go to roadresource.org. With that, I'll pass it back over to you, Dan and Jason, for question and answer.
Good deal. Well, hey, you know, I understand everybody's time is more valuable than ever this time of year as we kind of get cranking up into high gear. Thank you very much for spending it here with us, listening to me for the last hour. We hope you gained something from this. Take these slides, use these slides. We'll open it, as Allie said, questions and dialogue. I think Jason will moderate for us, but hopefully we can get you on the right path, if not answer directly. Jason, I know you want to do a survey first, which you pulled up, so I'll let you kind of lead the show here.
Yes, Dan. At the beginning of our webinar today, I asked for your time and your assistance in filling out an evaluation for us for future webinars. I really like that. I have it shown here. It's very simple. There's a little arrow with a little line to the right. Use that to go through them. There are about 6 of them. I ask you to please take your time to go through that, and we'll leave that up. As well as the file share, you'll see Dan's presentation PDF is there for download, as well as webinar series flyers for last year, as well as ones coming up for this year. Feel free to download those for your information. All right, Dan, we'll go through some of the questions, and didn't get very many, but maybe people are waiting until the end.
It's because I did so good. I was so thorough. No, I'm just kidding. Shoot.
And you did. Here's one question from Rich Shaw. Is secondary contamination or contaminant required for a loaded trailer on a job site if it's only there for the day during the scheduled work and leaves when emptied?
The secondary contaminant containment required or loaded. That's a great question. I have to imagine some of that depends on the agency. Secondary containment on the job site. I'm going to just speak from my experience. I've not seen that being required. I suppose if there's any agency folks or contractors that are from other regions than mine, again, I'm speaking for like Wisconsin and Minnesota, I've not seen it required, but I suppose that's something you would have to talk with the associated agencies about. But yeah, it's not been my experience. It's a good question, though.
Justin, if we could open up the phone lines, and if Rich is still here, if we're able to answer his question or not, I'd appreciate it.
Thank you. Ladies and gentlemen, if you wish to ask a question, please press *1 on your telephone. A voice prompt on your phone line will indicate your line has been opened. You may remove yourself from the queue at any time by pressing the star key followed by a digit 2. If you are using a speakerphone, please pick up the handset before pressing the corresponding digits. Once again, please press *1 at this time. Again, *1 for phone questions.
Thank you, Justin. So, Rich, were we able to answer your question? Or did you have a little more details that you wanted to talk about? I see Rich is typing. I'll give him a few minutes here. We had another question, Dan, from Zhao, about some applications like micro surfacing requires low temperature emulsion. in the summer to reduce setting speed. How is the proper handle? How do you properly handle this type of an emulsion?
That's a great question. I think I did touch a little bit on the specificity of microsurfacing emulsions. A lot of times folks will want them at very specific temperatures and much lower than what would come off the mill. So the first thing that we can do is just a simple heat exchanger right off the mill. Very, very common practice. So this would be cold water in one side, asphalt emulsion right off the mill in the other side, and it's a heat exchange. So we can bring it down to whatever temperature we want by monitoring flow rates. So if we want it at 120, maybe we cool it to 130 and we're good to go. The other thing is, we don't do it here, but some folks do, is you could cool the emulsion by running cool liquid, be it water, glycol, whatever, through heating coils in your tank as well. So a couple of options. Some materials perform better taking them through a heat exchanger, meaning it chemically will change how the emulsion reacts. Some will not, so it's just kind of working with your supplier. But heat exchangers off the mill, heat exchangers in the tanks, kind of the same deal. Cool it off.
Thanks, Dan. Great response. And Zoe, if you had any further questions, feel free to type them in. See, we have another question, Dan, from Jason. And I guess he's kind of responding to Zal's question. Some manufacturer uses heat exchangers with cold water and lower product temperature.
Well, here we go.
And then Tom Martin had a question about RPM of the mixer. I guess he's questioning what the RPMs of the mixer would be.
Yeah, so I think everybody that's listening probably knows what the answer is going to be. It depends on the size of the tank. Going to vendors that can help size these, what they'll typically do is model the tank given the liquid viscosity in the tank at the temperature you intend to store it, and they'll size the mixers appropriately. You could be on the order of hundreds of RPM. It's higher than you might think, but it's not crazy. But really, that's a question that has to be worked out based on your specific tank geometry and with the vendors that size those things.
Thanks, Dan. We had a question from Hamid. What are your recommendations for users QC testing to assure proper storage and delivery?
What are your recommendations for users QC testing? I'm not sure I fully grasp what we're aiming at here. So like, I can just tell you what we're required to do in the state of Wisconsin is a member of what's called the Combined State Binder Group. So we have certain requirements that we need to submit for given materials at a given time interval. So we are defaulting to what our regional agencies are requiring us. What are you recommending? I guess I'm not exactly sure if that answers it.
Let me take a stab at this, Dan.
AASHTO guidelines. Yeah, go ahead, please.
As a contractor, you guys would be the quality control aspects of a project, and I think what he's looking at as an agency is quality assurance. On the quality control side, what would be some of your thoughts of what some recommendations would be for a contractor, say at storage and handling? Are there some things that that you would recommend as something that needs to be quality control checked?
Well, I think the easiest things to do would be have the ability to run the simple compliance tests like viscosity, like residue percentage, even penetration. You know, the emulsion industry still works on penetration. Because you can generally tell if something's going wacky with those kind of simple tests. A lot of times that'll give you some indication without kind of breaking the bank, and you don't have to go through full distillations and things. So, I mean, that's kind of like what we would do. You know, we might not do full compliance testing every single day on every single tank, but we might run product viscosity. And if we see it change significantly, we know something's wrong. We have to look at it a little bit further.
Good answer. Thanks, Dan. And I see Oak had a question. For other agencies, do you sample on the job site? And if so, do you sample per gallon, per ton, or per truck? So the other people out there, audience from the agencies, would like to answer either by phone or by the chat, feel free.
We should have, Jason, we should have made this one a question on the poll, because this one is different for every agency, it seems like.
That is, I agree. Justin, could you remind folks if they want to take their phone off mute, *6, is that correct?
I'll be happy to remind our audience, once again, if you would like to signal with questions, it is *1 on your touch-tone telephone. Again, that is *1 if you would like to ask phone questions. We'll pause for a moment.
Thanks, Justin. Well, Dan, as you were saying, there's a variety of agencies out there with different perspectives on that, and I would have to agree with you, and doesn't seem like we got anybody out there wanting to respond. But good question, Oak. Yeah. I see LaRose is typing in from California. Thanks, LaRose. Caltrans usually samples per truckload. So thanks, LaRose. I appreciate your response. See, Bill is typing in. Thanks, Bill. I do believe we had some folks from Virginia as well, and trying to think of some of the other, as I was sending out emails from other localities. The Oak's typing away. Oak, and you will see on one of those slides toward the end that Dan was talking about on storage was one of the documents that we got from Montana, that storage and handling, kind of a document that used. I took that as kind of share to others. See, Bill, sample at the plant. Okay, thank you, Bill. Well, as folks are typing away, here, Oak, thank you. The issue we see is trucks offloading in the middle of the night when our inspectors aren't there. So I'm trying to figure out if the truck is the way to go. All right. Well, Dan, while folks are typing in, I want to say a great job today. Excellent presentation. We appreciate your time, like Ann mentioned. We do appreciate your time, and excellent presentation. And I see Nye from Arizona. Thanks, Nye. I forgot about you. You sampled per the truck too. Nye, do you see any issues with your inspectors, you know, with the trucks, like Oak was saying, loading at these at nighttime? Do you see any issues with that? Or LaRose, did you see any projects for Caltrans with this being an issue? Hate to put you on the spot. Not usually. Most loads arrive just prior to starting of the day. Thanks, Nye. Appreciate your comment. All right, *1 if anybody else has any questions. So we got a few more minutes. You're welcome, Oak. All right, Dan, I'd like to give you over the floor and any last comments.
No, thanks. I think there's good discussion. I have really nothing else to add. I think if my contact information is listed, there are specific things that you just feel more comfortable reaching out, please take this as an open invitation to do so. Otherwise, thank you again, everybody.
We appreciate everybody's attendance today, and you all be safe and have a wonderful rest of your day and a good weekend. Thank you.
Thank you. That concludes our conference for today. Thank you for your participation and for using AT&T teleconference service. You may now disconnect.